Welcome to my video on one of the most fundamental algorithms in machine learning, k-nearest neighbors or KNN for short. Whether you're a beginner just starting your journey into the world of machine learning or an experienced data scientist looking to expand your toolkit, KNN has something for everyone. By the end of this video, you'll have a solid understanding of KNN and be ready to apply it in your own projects. So let's jump right in and uncover the secrets of KNN. What is the k-nearest neighbors algorithm? This is a non-parametric supervised learning classifier that can be used for both classification and regression tasks, which uses proximity as a feature for classification or prediction. It is a classic example of lazy learner algorithm because it does not learn from the training set immediately, instead stores the data set, and at the time of classification it performs an action on the data set. Let's imagine that we have a couple of data set points scattered across a 2D space. Each point represents an observation and its position is determined by its features. Now let's say we have some labeled points here. We have red triangles as an anomaly, green squares as normal points, and one unknown pentagon. We want to classify this new data point, the unknown pentagon, based on its proximity to the other labeled data points. Now, what do I mean by proximity? So, by proximity, I'm considering it as the Euclidean distance. The Euclidean distance is a measure of a straight line distance between 2 points in the Euclidean space. For reference, the 2 points here are A and B, and the distance is shown by D. Another option for calculating proximity is the Manhattan distance, which is also known as the city block distance, which calculates the distance between 2 points by summing up the absolute differences of their coordinates. Let's dive into how KNN works. The term nearest is, as mentioned again, determined by the Euclidean distance. So once we have a set of k, a number k, here k is the number of nearest neighbors to a certain point that we want to find or we want to classify. Once we look into the first diagram, the new example to classify is given by the question mark. There is a class A, which is red stars, a class B, which is green triangles. Now we calculate the closest points for the question mark. Here, so for example, if we take the value of k is equal to 3, we calculate the closest 3 points to our question mark, which coming to our third diagram, where finding neighbors and voting for labels. The closest 3 labels are denoted by the dotted circle, where k is equal to 3. 2 of them are 2 green triangles and 1 is a red star. Now based on this, we can say that our point is closest to the green triangles and it resembles a green triangle, so it will be classified as a green triangle. Moving on. Another example. So before training, we have a couple of positive reviews classified by the blue squares and a couple of negative reviews classified by red squares. And we have one query data point which we intend to classify. Now after training, we can see that the blue squares are much closer to the query data point, hence the query data point is classified under the positive review class. Now, how do we choose the value of k? Choosing the value of k, the choice of the value of k is a critical parameter in KNN. A smaller value of k leads to a more flexible decision boundary, while a larger value of k leads to a smoother decision boundary. It is essential to choose an appropriate value of k based on the data set and the problem at hand to avoid underfitting or overfitting. Some of the advantages of using KNN. To begin with, KNN can be used for both classification and regression predictive problems. We generally look at 3 important aspects when we evaluate any technique: the ease of interpreting the output, calculation time, and predictive power. KNN classifier is fair across all parameters under consideration. It is commonly used for its ease of interpretation and low calculation time. Some of the other advantages are listed here. The effectiveness of KNN increases with large training data, so it supports sufficient data representation. KNN can be used for both classification and regression. The other two I mentioned prior. Some of the disadvantages of using KNN is that measuring the distance between all the data points in the training samples is a computationally expensive task. It might take more space and more time. The bigger the data set, the longer it takes. If the training set or training data is excessively randomized, then assigning a class label based on distance measure is messy. KNN is not suitable for query points at farther distance from the training data. Now let's look at some of the uses for KNN. Starting with classification. It's widely used for classification tasks where it assigns a class label to new data point, majority on the majority class among its nearest neighbors. Okay. It is effective for both binary and multi-class classification problems and is particularly useful for data sets with complex decision boundaries. Coming to collaborative filtering systems, which are for recommendation systems. In collaborative filtering recommendation systems, KNN can be used to identify similar users or items based on the feature vectors or by finding the nearest neighbors. And it can also recommend similar items to the user or predict the user's preference for a particular item. Next, anomaly detection. It can be used for anomaly detection by identifying the data points that are significantly different from their neighbors. Unusual data points that have few or no nearby neighbors may be flagged as anomalies. This makes KNN useful for detecting fraudulent transactions, network intrusions, or other abnormal patterns in data. Next, regression. While KNN is primarily a classification algorithm, it can be adapted to regression tasks. KNN is suitable for predicting numerical outcomes such as house prices or stock prices. And for clustering. Although KNN is primarily a supervised learning algorithm, it can be used for unsupervised tasks such as clustering by treating each data point as its own cluster and finding its K. And KNN can partition the data into clusters based on similarity. This approach is known as KNN-based clustering or nearest neighbor clustering. Congratulations, now you've learned the basics about K-nearest neighbors classification. Here in summary, KNN is a straightforward classification algorithm that relies on similarity of data points in the feature space. By finding the K-nearest neighbors of the new data point, KNN can effectively classify observations based on their proximity to labeled data points.